Unit 10, Lesson 4, Solving Equations with Algebra Tiles. How we can solve equations using the algebra tiles. Before we introduce the lesson, I like to share with you two definitions. These two definitions are very important. We need to understand the difference between the two. An algebraic expression is a mathematical phrase that contains ordinary numbers, variables like x or y, and operators like addition, subtraction, multiplication, or division. So let's start with an example. If I have something like 3x minus 2, this is a good example of algebraic expression because it's a mix or a phrase that contains all of what we mentioned. 3 is a number, x is a variable, 2 is a number. The minus here, or this operation, the minus operation or subtraction, it's operation. And even there is a hidden operation which is multiplication between the 3 and x. So it's a mix between numbers, variables, operators. Another example, 4x by itself, algebraic expression. It has a number, it has a variable, and it has a hidden operation which is multiplication. Someone will tell me, what about number 5? Could be algebraic expression? Yes, it's a number, and actually there is an operation multiplication by a variable exponent 0 that it makes 1. That's why it's hidden. We will understand that after. So as you can see, this is 3 different examples of algebraic expression. Now let's go to the second definition, an equation. An equation is a statement that two algebraic expressions are equal. That means if I can get any two algebraic expressions and I put the sign equal, it's an equation. The word equal here is very important, that's why we call it equation. So 3x minus 2 equal 1. Can you see the difference between this one and the first one? The first one was 3x minus 2 and there is no sign of equal. As soon as I see the equal sign, we call it equation. Because there is an algebraic expression in the left side and there is another algebraic expression in the right side. They are equal, that's why we call it equation, because there is an equal sign. This is the difference between the algebraic expression and the equation. So if we understand this one, we can go to the second step. Recall. As you know, we can use colored tiles to model integers. So if I have a square tile like this and it's red, this is to introduce a model with -1. So I can model -1 with a negative square, as you can see. So this is the first one. Second one, I can model a positive integer or +1 by using a positive square. So if I have a negative square, this is to present -1. Positive square, this is +1. Both of the positive and the negative together, they form zero pair. What the meaning of zero pair? If I have +1 and I add a -1 to the +1, together they will give me a zero pair. So if I have -1 as an integer and I add to -1 a +1, imagine if you lost $1 and someone returned this dollar to you. That means you didn't gain anything. That means zero pair. Excellent. Let's go to the second one. We will see a small difference. We will see now there is a rectangle we can use a color rectangle tiles to model variables. So I need to fix this one. It's not integers, variables. This is the difference between rectangle and square. Square for integers, but rectangle for variables. So if I have a negative rectangle, that means I can model negative x. Can someone tell me, can I introduce negative y? Yes. Can someone tell me negative m? Yes. Can someone tell me negative r? Yes. Any symbol, any variable by negative. Excellent. What about a positive rectangle? Here I can model the positive x or the positive y or the positive n or the positive r. So the variable was positive. So as you can see the difference between the square and the rectangle, the square for integers, the rectangle for variables. What about if I introduce both of them together? Together it's gonna give me again a zero pair. So if I add a negative rectangle to a positive rectangle, that means what I'm doing, it's like that. Negative x plus positive x. I have a negative x plus positive x. Right away it's gonna give me zero pair. Someone will tell me why we need the zero pair. We will see it right away, how we can use the zero pair to solve the equation. So the next one is the most important part. This is a question. Solve 2x equal 6 minus x. First of all, the word solve means what? This is first question. The second, this is what? First of all, if we talk about this one, this is not an algebraic expression. Actually 2x it's an algebraic expression, 6 minus x it's another algebraic expression. There is a sign of equal, that means this one it's an equation. This is what we got from the definition. So I have an equation. When the question is saying solve an equation, means what? Find the value of the variable. Where is the variable here? 2 it's a number, 6 it's a number, x is a variable, so x equal what? This is the meaning of solve 2x equals 6 minus x. Now I can solve this with an algebraic way, but our lesson how to solve it using the algebraic tiles. So if you have an EKO exam and they ask you to solve the equation with algebraic expression, you cannot skip it. You cannot solve it with algebraic way. You have to solve it with the algebraic tiles if they ask you to use algebraic tiles. So let's see. 2x equals 6 minus x. I'm gonna try to draw the tiles that it related to the left side. 2x, that means I am using variable. That means I'm using rectangle, not square. They are positive or negative. As you can see, positive 2x, that means positive. So I'm gonna choose a green color and I'm gonna draw 2 rectangle with green color. So again the question, why I am using 2 green, positive like that? Because I have 2 positive variable. Excellent. Now instead of saying equal, we're gonna separate it with a symbol with this way. Now the right side, I have number 6. 6, that means number, not variable. That means I'm gonna use square tiles, not rectangle. What the color of the square, positive or negative? They are positive, so I'm gonna use the green color. Excellent. So first one, 1, 2, 3, 4, 5, 6. And don't forget, for yourself, it's better to put the plus inside to remember that this is positive tiles, and this is in case you are drawing with a pencil and it's not colored, so it's better to put the positive sign. Minus x. Instead of operation here, there is nothing to use squares or rectangle for the operation, so I'm gonna take it as negative x. That means I'm using variable. That means I am using red rectangle. Why rectangle? Because it's variable. It's not, in this case, it's not a number. Can you see? So this is exactly 2x equals 6 minus x. So if you hide this equation and you tell someone, can you read this one? He's gonna tell you, yes, this is two variables because rectangle, positive, that means 2x, equal, I see squares here, they are 6, that means number 6, and there is one variable, which means x, but negative, so negative x, 6 minus x. So this is how we solved. Now, how to solve the equation? To solve the equation, we need to gather all the variables in one side and all the numbers in the other side. So as you can see, for me, it's easier to switch all the variables in the left side and all the numbers in the right side. That means we want to see all rectangles in the left side and all squares in the right side. So how to do this one? I have to think, well, I need to move this red rectangle from here. I don't need it. I need to isolate these 6 squares. I don't need a rectangle here. How to do it? This is the idea. I can add a green rectangle here. And this green with a positive sign. Someone will tell me, now you are changing the equation. No, I'm not gonna change the equation. Whatever I'm doing at the right side, I'm gonna do it at the left side, so no one can tell me that I'm changing something. Okay, so that means I have to add another positive rectangle in the left side. So no one can tell me that I changed the shape of the equation. This is exactly like if I have 3 plus 1 equal 4. Can you add to the 4 1? It's gonna be 5. That means I have to do the same thing in the left side. Whatever I added here, I added at the left side. So 3 plus 2 now equal 5. 4 plus 1 equal 5. That means the equation is true. So whatever here, I did it. If I add 1 here, I have to do it here. Whatever you change in the right, I have to change it in the left, or do the same thing. So now, someone will tell me, but why did you do that? The reason is very simple. I need to get a 0 pair. I need to have a 0 pair. Can you see? This is my goal. Someone will tell me, why you are doing that? Because I need to say I have 0. Done. I don't have something here because I know that one positive and one negative variable together, they're gonna give me a 0 pair. And this is exactly why we explained it at the beginning. This is the benefit of 0 pair. To remove this red variable from here, so as you can see the result, it's gonna be all rectangles in one side. That means all variable in one side. At the right side there is only numbers. Excellent. Now what do I need to do? I have three variables here and I have 6 numbers here. So they are saying to find the value of x, because this is my goal, I can arrange a little bit what I'm doing. So can you see this 3? I'm gonna leave it as it is. 1, 2, and 3. And don't forget to mention the sign. and I'm going to repeat the equal with this shape, and instead of having 6 squares in one line, I'm going to rearrange it with a way that it's going to be equal between all variables. That means I'm going to put 1 and 2 in front of the first variable. Again, another 2 in front the first variable, because I need to divide it equally between the variables. And I will tell you why I'm doing that. As you can see, I have 6. I didn't change anything. So it's the same value, 6 numbers here, positive, 6 square tiles. The reason I'm doing this, to show that each variable equal 2. That means x equal 2. And this is my answer. Wow. Can you see? Now, someone will tell me, okay, how do I know that what I did is correct? Verification. Very important. Verification. Verify your work. How we can do the verification? We can substitute x by 2 in the equation. So I have 2x equal 6 minus x. This is the main one. Replace or substitute x by 2. Let's see. If the left side equal the right side, you did a good job. 2 times 2 equal 4. 6 minus 2 equal 4. Left side equal right side. Done. That means all my work is correct. Let's see another example. Solve 3x minus 8 equal negative x. Okay, so let's do it. I'm gonna try to make it more quickly now. We understand 3x, they are positive. I'm gonna use the green, and as you know, I'm not gonna use square, I'm gonna use a rectangle. So 1, 2 and 3, and don't forget to mention the sign to make sure that you understand that this is 3 positive x. Minus 8, I cannot introduce the minus, so negative 8, that means I need to use the red color but with 8 squares. 1, 2, 3, 4, 5, 6, 7 and 8. So this is to introduce negative 8. Don't forget again to introduce the sign to make sure that you understand that this is negative. Now the equal sign to separate the left side from the right side, and I have negative x. Negative x means I need red color and I need to introduce not a square but a rectangle, and don't forget to mention the sign. Excellent. As you can see here, there is a mix between variable and number in the left side, but in the right side there is only variables. What do you think? Why I don't leave the 8 square, which is the numbers, in the left side, and I transfer this 3 rectangle to the right side? Okay, to transfer it to the right side, that means I need to move this 3 from here. I need to isolate the 8 squares here in the left side. How to isolate it? We don't have a choice. We need to add 3 rectangles red. Someone will tell me why I have to do this. Because my goal is to reach 3 0 pairs. This is the main issue. So negative, negative, negative. So as you can see with the blue, I can say this one with this one 0 pair. This one with this one another 0 pair. This one and this one, another 0 pairs. So that means I can say to all of that bye bye, 0. There is no value for this one. But before I forget that I changed something and I was adding this 3, I have to do the same change in the right side. If I added 3 rectangle with red, I have to do the same thing in the right side to make the equation true. Because someone will tell me, no, you changed the shape of the equation. But now I can say, no, I didn't change anything, because whatever I did it in the left side, I did it in the right side. Again, negative, negative, negative. So the result at the end, I see now in front of me squares only in the left side, and in the right side rectangle. So let's see the value. I have what? I have negative 8 here, and I have negative x here. That means what? That means I can replace or change little bit this with a nice way to facilitate the value. That means what? I can put 2 square in front of each variable to make it equal. I have to distribute the 8 between the 4 variables. So this is the best way that I can do it. And don't forget to mention the sign. And after that, this is the equal, and after that I will repeat the 4 rectangles. So I didn't change anything. I'm doing an organization only to get the value of x at the end. This is my goal. But the same amount are here, 8 in the left side and 4 in the right side. As you can see, I didn't change anything. And now if I want to change that as writing, I'm going to say that negative 2 equal negative x. And you will get after that, if I switch the place, I can say that x equal 2. Now I need to do a verification, because I'm not sure if my work is right or wrong. So I can check verification. And this is what I need that you do in class to make sure that your work is correct. 3x minus 8 equal negative x. Substitute x with 2. So 3 times 2 minus 8 equal negative 2. Is it correct? 3 times 2, 6. Minus 8 equal negative 2. As you can see, 6 minus 8 equal negative 2 equal negative 2. Thank you.